Good afternoon again, and welcome to Science Review with Mr. Blades. Now, we've probably just started doing motion graphs in class today, and we're going to go ahead and go over some of the stuff that we probably covered in class and do an example. All right, so let's come along. Now, you can see up here on the board I have 3 motion graphs. They all look the same, but they have a few key differences. Now, this one right here has X on the y-axis and T on the x-axis. This one has V on the y-axis, and this one has A on the y-axis. From that, you can probably tell that this first one here is a position versus time graph. This one is a velocity versus time graph, and this one down here is an acceleration versus time graph. Now, each one of these shows how position, velocity, or acceleration change with respect to time. Now, I've drawn them all to look the same to illustrate that while they look the same, they indicate very different things. Now, in our position versus time graph, we see that the position started somewhere not at 0, which means that this person or this object did not start at its designated origin point, and its position is becoming more and more positive. That is to say, it is moving away from the origin point in a positive direction. Okay? Here we go. Now, moving on to our velocity versus time graph, we will see that, again, our velocity did not start at 0. That means from the very moment that we started paying any attention to this, the velocity was already greater than 0. So for this entire time, this object was moving. And again, the velocity became more positive, which means that the magnitude of the velocity was becoming greater in the positive direction. And then last, same deal with the acceleration graph. We have an acceleration that started at something greater than 0. It was accelerating from the very beginning. And again, its acceleration was increasing throughout the time period that we paid attention to. And that means that it's accelerating in the positive direction. Okay? Now, they all look the same, but again, they indicate very different things. Now, each one of these lines is supposed to, barring my artistic ability, supposed to have the same slope. And again, depending on which one you're looking at, that slope means something different. Okay? So, the slope of this line in a position versus time graph indicates how quickly the position is changing. And if you think about it, what is another name for how fast a position is changing? And that is velocity. Velocity is the rate of change of the position. So the slope of this line would tell you the velocity at any given point in that graph. Likewise, over here at velocity, the slope of that line tells you how fast velocity is changing. And the name we have for that is acceleration. Acceleration is a measure of how fast a velocity is changing. Lastly, the slope of this line down here in the acceleration versus time graph would tell us how quickly the acceleration is changing. We don't have a different name for that, but it still shows us how fast the acceleration is changing. So hopefully this was a nice little review for you, and good job, and I'll see you in class.